Okay, we're going to go ahead and get started now. Welcome to day 5? Day 5. Oh, it's all blending together now. We're almost halfway. So, today, for example, we're going to hold a class if Eric Tang will be quiet. I'm just going to... Such a jerk. You have documented proof that I'm a jerk. This is recorded. Okay, last time we covered strings, and I just want to know, we won't go over it so much because I've decided to leave some of the review out in order to leave time for more coding. But does anyone have any questions about strings from last time? Any questions at all? Anything unclear? I heard I made a mistake on the video and called curly brackets square brackets, so I am sorry. I am sorry.
You should.
Okay. What a fool. Okay, today we are going to learn the most important lesson in all of computer programming. So please, I don't know, buckle down? I don't know. I'm just kidding. This is a very important lesson, okay? Until today's lesson, we have been writing code, and all of the code executes from top to bottom, and the program is basically the exact same every time. We might feed different input into it through the console, right, and make it say 55 or 65, depending on what we type, or do some math. Okay, but today we are going to learn the essence of computer programming, and that is selection, it's called. Selection or logic. Okay, we're going to learn how to make our computer program make decisions, and this is, of course, very important. For example, imagine a GPS program that's guiding you to Walmart in San Francisco when you go to visit there next summer, right? Imagine a GPS trying to route you on a route from Walmart to your current point without making any turns. You'd have to be right next to Walmart for that to happen, right? Or in an airplane. Okay, so we're going to teach our computer programs how to make decisions today. There are several things we need to cover, so let's go ahead and dive in. Okay, very first, I draw your attention to this chat with Stephen Ting. And next to the Lunch Learning Wiki, where you will find day 5 information. Okay, this table right here, we're going to spend some time talking about this table. Just like on the day that we learned variables and arithmetic, we learned some operators, right? We've got a whole new set of operators that will help us make decisions or do selection. Okay? And for some reason, somebody keeps moving around the wiki. I don't like it when that happens. Yeah, apparently anyone can edit this wiki, so go nuts, buddy. Anyway, here are the operators that we're going to talk about today. The first 3 are called logical or Boolean operators. And the reason we have a data type called bool, and we say Boolean logic, is because a British mathematician, George Boole, invented this type of logic, and really it was the start of the computing era. We wouldn't be able to do computer programming today without his work. So, moment of silence for George Boole. Thank you. Okay, there are 3 operators that I would like to talk to you about right now, and, or, and not. Okay, these are common parts of English, and if I were to say I would like pickles and lettuce and tomato and not horseradish, or I would like a pizza, that's a sentence that you and I can understand, right? I want a sandwich with those specific toppings, but if you can't do that, give me a pizza. Okay, that's what these operators do in our program, right? So the AND operator, you can see an example here. It says if the condition on the right hand and the left hand of the AND operator are true, then the AND operator will generate a true for us, right? So this example right here, I have a variable, bool loves to code, another bool loves sunlight, and one is set to true, one is set to false. So what will the value of answer be after this line of code? It will be false because we're saying true and false. I love code and I love sunlight. No, I don't, right? So true and false is false. Okay, and we're going to do a truth table exercise here in just a minute to help you practice that. Or you can see here, it's just two vertical pipes, okay? Hopefully you can see that. Why not? I'll put the cursor there so it looks like three vertical pipes. Okay, or says if either condition on the left or the right-hand side of the operator is true, then return true. Okay, so we have the same two variables, loves code, loves sunlight, but instead of sandwiching an and in between them, we sandwich an or. The value here is true, even though one of them is false. We're basically saying true or false is true. True and false is false, okay? And then the final Boolean operator that I want to talk about is the negation operator, or not, okay? The exclamation point in C# is used to say not. It's used to invert, it's used to negate, it's used to say take this variable or this condition and give me the opposite, right? So my 7-year-old daughter, this is her favorite operator because she's just obsessed with opposites. And we hear it every day. Brush your teeth. No, eat a cookie. It's really hilarious, right? So those are some logical operators. Let's write some statements real quick to practice with those logical operators. Okay, I want to write some code that models my food order here. So very first, I'm going to say bool has pickles equals true. Bool has lettuce equals true. Bool has horseradish equals false. Okay? And then bool, gimme a pizza, true. Okay? If I want to model the sentence that I just said a little while ago, give me a sandwich that has pickles and lettuce and horseradish, or give me a pizza, how can I use these operators to make that sentence a statement in C#? So the way I'm going to do that is I want to say I want pickles and lettuce and horseradish, or give me a pizza. Okay? Bool, food order. There, we'll make it compile. How about that? Okay, just like our arithmetic operators, there is an order of precedence here, and an or have the same precedence. So we go from left to right, and if I want to make sure that one or the others of these is true, I can group them with parentheses just like I can with math. Okay, so I can change the order of operations here with math. So this statement's going to come in here and say, first off, evaluate, is has pickles true? Yes. And is has lettuce true? Yes. And is has horseradish true? No, it's not. So everything inside of parentheses here turns up to be false. Then I say false, or give me a pizza. The value of that is true. So what is the value of food order? True. Exactly right. Okay, we're going to do some complicated ones here in a minute. If you look on the truth tables, we're going to take some time there here in a minute. Actually, let's do it right now that we've talked about logical operators. So I'm going to give you guys just a few minutes to go through and fill out these truth tables, then we will fill it out together. The truth table looks a little something like this, okay? So you've got a couple different variables, 3 different variables in each truth table. So you've got X, Y, and Z. Each row is a scenario. So in this scenario, X's value is true, Y's value is true, and Z's value is true. So I want you to evaluate X and Y and Z. So true and true and true is true. Okay, go ahead. I'm going to pause the recording at this point. Fill out these truth tables. We'll resume here in a few minutes, and then we'll go through it all together.
Anybody missing the paper or pen?
You also don't have to go through it if you don't want to. We will review the answers. One moment.
So be really
I've resumed the recording here, so let's go ahead and work through these. True and true and true. I want a right hand for true and a left hand for false after each of these, okay?
Who's left and right hand?
Your right hand
Is true.
is true, your left hand is false. All right,
Okay.
ready? 1, 2, 3. Why are you all holding up your left hand? This is wrong. I'm just
Right hand is
right.
true.
True and true and true is true, right? True and false is false. That's right. When all of the variables, when we're saying you and you have to be true, we're saying everyone has to be true. So if there's even one row here that has a false, it turns out to be false.
Yeah.
Okay? Just opposite of that, when we're saying you or you have to be true, we're basically saying if any one of you are true, then the line is going to be true, right? So if there's any true on a line, when it's or, then it's true. Okay, I did misspeak a little earlier. And has a higher precedence than or, but just barely. So we always do ands first. So let's do this one, a little tricky. You may have gotten it wrong because I misexplained it, so everyone gets all of the credit back for this assignment. So what do we do first on this line? We do x and y. We evaluate that. X and y on the first line are true. So true or true is true. Okay. X and y are true on this line. True or false is
True.
okay. X and y, true and false. True and false are false. False. Yeah. Yeah. I said the whole hand thing and then I went away from it. I'm sorry. Yeah. How you doing? Okay. So true and false is false, and then we do the or. True. So the whole statement is
True.
right hand, I think you meant. Okay. Anyone have, here, we'll just go through them real quick. We won't spend a ton more time on this. So this is false. This is true. This is false. This is true. False. Here we go. True.
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 True. True. False. 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 Very good. Okay. Check your work. You may have a cheese stick.
Wait.
Oh, okay. Okay, sorry. Here we go.
No, wait, hold on. The third one from the bottom, shouldn't that be true?
Third one from the bottom in this table.
Yeah.
Y and Z is
Y or
false,
is X or Y.
but we do and first. And this is where we're getting caught up
Okay.
because I misspoke. We always do ands first because it has a higher precedence. Yep. So 1 point of extra credit for everyone.
Yes.
We do Y and Z first, and that is false. And then we say false or false. False.
Super smiley face with a stick out.
So wouldn't that make the second one down false?
The second one down, this one right here, true and false
That X is true.
is false. And then we say false or true
Y and Z
is false.
false.
Or X.
And then or X.
I'm with you.
If you can't see me, I'm doing hand signs at Shelly right now. Hand signs.
Put that one finger down.
Oh,
Shooter with
not
that.
those ones. Okay, those are our logical operators. Let's keep moving. We have relational operators too that hopefully you're a little more familiar with. If we look on the wiki, the relational operators are right here. And we kind of used one last time, the equality operator, okay? These are used for comparison, and they also return a true or a false. As we learned last time, the double equals sign checks to see if the value on the left side of the double equals sign, or equality operator, is the same as the value on the right side. Okay, so in this example, we have a variable, what I want, chocolate, what I need, exercise, and proceed is equal to what I want is equal to what I need, and of course that's false. Right? So equality checks to see if the thing on the left is equal to the thing on the right. Greater than checks to see if the thing on the left is greater than the thing on the right, less than, and so forth down the line. With this one being a little tricky, this is a not equal to, okay? So if the thing on the left is not equal to the thing on the right, this one actually returns true, which is, anyway, it's a little backwards, but when we're checking to make sure that something isn't equal to something else, we use not equal. So let's do some examples. Okay, let me make sure I'm not about to do one of the coding practices for you, because sometimes I do that. Okay, it will be very similar. You're welcome. So let's write a program that asks a user for a number, and then we make sure that the number is, we're going to tell the user, give us a number greater than 1 million, and then we will check to see if it really was. All right, so we're going to do a console.writeLine, give, with quotation marks every time, give me a number greater than 1 million, holds pinky to face. Okay, and I'm going to change this to a console.write because I want the number to be on the same line. And I'm going to do a int number is equal to, we want to convert it. Well, first off, let's get the number. Console.readLine. So this reads all of the characters that were typed before the user hit enter. And of course, it's yelling at us and saying you're trying to put a string into an int. So we need to do a convert to int 32. This will convert the input into a number if possible. Okay, and then we're going to do a console.writeLine. The number was greater than 1 million. And then our answer, number greater than 1 million?
Yep.
Okay. And it's yelling at us because we need to do concatenation. What? What's your problem? Okay, let's go ahead and run this and let's talk about what is going to happen. Okay, we know console.write, we already know that writes output to the console. We know console.read, that gets input from the console. Okay, I type in 2 million, press enter, and then we're going to do this comparison. Is 2 million greater than 1 million? True. All right. So these operators, hopefully we're all familiar with. Greater than, less than, greater than or equal to, less than or equal to. Let's talk about the not equals operator because sometimes this is a little tricky. Give me a number that is not 1 million. Okay. I'm going to change this to do the not equals operator. The number was not equal to 1 million. Save this. Let's run it. I'm going to type in 1 million because I'm disobeying. All right, what do you think? What's going to be output on this line? Anybody for true? You're also smart. Very good, very good. Okay, those are our relational operators. Now here we have learned how to write some good conditions, right? We could write very complex conditions by chaining together many operators, many variables, and the way we want to make our computer program make decisions is with what's called an if statement, okay? There are a couple different ways to make your computer program make decisions, but we are just going to focus on if statements. For your information, there are several others. You may read about one of the others on the wiki. I have a tutorial to what's called a switch statement, but just for sake of time, and we're going to skip switch statements right now, and we're going to talk about if statements, okay? An if statement is a very powerful thing. If I were to show you in our code base here at Health Equity how many times the word if is repeated, I'm guessing it would be over 1 million, right? There are, I mean, it's the essence of computer programming. Really it is. To allow your computer program to make decisions, okay? Here is an example of an if statement. Enhance. All right? You can see a couple parts to this if statement, all right? Very first, the keyword if has to be used, okay? It's lowercase if. Next to the if, following the if, is a set of parentheses, okay? This is kind of like saying if the condition inside of parentheses is true, then the thing that follows that is a set of curly braces with one or more statements inside the curly braces. So essentially we're telling the computer program, if the condition inside of parentheses is true, then do all of the statements inside of curly braces. Conversely, if the condition inside of the parentheses is not true, skip all of the statements inside of the curly braces, okay? That is an if statement. So let's write one. Let's do this program. I'm gonna go ahead and revert some of my changes here, right? Give me a number that is greater than 1 million, and I want to do an if statement now, okay? So now I'm going to write the keyword if, and then I'm going to write a set of parentheses. And just as a good habit to make sure I get all the characters, I'm going to write the curly braces. All right, now I'm going to go back and fill in the condition or the Boolean statement that's inside of parentheses. So if I want to do something, if the number is greater than 1 million, inside of parentheses I will type if number is greater than 1 million, okay? Now, anything inside of curly braces here will only be executed only if that condition is true. I'm going to add a great job message here. Okay, I have told the computer program to make a decision here now. I'm saying only if this condition is true should you do this line of code. So let's run this program. I'm going to save. And I'm going to type in 42, which is supposed to be the answer to everything, and nothing happens. Why? What's false?
Less than 1 million.
42 was not greater than 1 million. So this condition was found to be false. So the statements inside of curly braces for this if statement were skipped. They were not selected. Okay? You see now, this is how we make the computer program make decisions. Right?
Can you do an if not? Have you done?
Well, as if I planted the question. Okay, the question was, can you do an if not? And the answer is yes. The way you can do that in computer programming, and especially in C# is with an if-else statement, okay? So an if-else statement is very similar to an if statement. It's got the keyword if, it's got parentheses with a condition inside of it, and it's got curly braces. If this condition is true, then we'll do the statements inside of curly braces. But if it is not, we specify statements to be executed in an else and curly braces, okay? So if this condition is true, this will happen. If this condition is not true, this will happen. So you could almost call this keyword otherwise, right? But it just so happens this is a C-based language, and in C, when that was created, they used else, okay? If this condition is true, do this line. Else, do this line. So let's try it. Here we are in our handy little program that will tell them great job. So if they did not do a great job, we don't do parentheses again, right? Because this is just we've already determined that this condition was false. So we want to skip down to this block. We're going to tell them bad job. Okay, let's run it. Let's save it and let's run it. So I'm going to put in 42 again. Someone predict what will happen.
You did not do a bad job.
So this condition, we hit this if statement. This condition was found to be false. So we skipped the lines in that, or the statements that were inside of the curly braces of the if statement, and we did the lines inside of the curly braces of the else statement, right? So we've created a branch in our program. We've said, at this point in the program, go right or left. Go left or right, go true or false, okay? So the final one I want to talk about is an if, else statement, okay? So far, we've learned that we can make statements be executed if one condition is true. We can pair two groups of statements if a condition is true or if the condition is false. And with an else if, else statement, we can have an unlimited number of conditions, though you might get yelled at if you write a really big if, else if statement, okay? Here's an example of it. So you can see we've got all of the elements of an if-else statement. We have the if, a condition, curly braces with a statement inside of curly braces. Skipping to the bottom, we've got an else, curly braces, statements inside of curly braces, but in the middle, we've got this else if with parentheses and another condition. The way that this works is we hit this if statement, we check this condition to be true or false very first. If it's true, we step into here, we do these statements, and then we skip the rest of the if, else statement, okay? If this condition is false, we're not going to go right to the else block. We are going to go to the else if block. So this has to be false, and then if this is true, we step in here and do these lines of code. It would be really awkward if you couldn't see my cursor. Can you see my cursor? Somewhat? Okay. Because I keep just saying this. Okay, if this condition is false inside of the if this condition is false inside of the else if, then we will bump down to the else. And just know that with an if, else condition, the else is optional, right? So if I want nothing to happen after 3 conditions are checked, I just leave the else off. So let's practice this. I'm going to get rid of this example, and I'm going to say console.writeLine, console.write, what day of the week is it? I'll tell you the lunch menu. So obviously, if we're asking what day of the week it is, how many conditions can there be? 7, right? So let's write some code to check, will an if statement allow us to do this? The answer is actually yes, but for the purposes of this example, we're going to write it with an if statement. We could not do this with an if else statement. Well, yeah, we could, but it would be really bad. So let's do this. I'm going to come in here and I'm going to say if, well, first off, I'm going to get the input, var day of week is console.readline. So we're going to ask the user for what day of week it is, then they're going to type it, then we're going to store it in this day of week. Then I'm going to say if day of week is equal to Monday. We're going to do this. I'm going to create a variable outside of the if statements. This is important. If I create a variable inside of a set of curly braces, it is not going to be available to me outside of curly braces. This is something called scope. The scope of this variable is inside of these curly braces. It cannot exist outside of curly braces, okay? So if you need something before and after an if statement, you need to declare your variable before. I'll just show you here. If I try and refer to lunch menu right here, it's going to throw an error and be like, I don't know what you're talking about. Right? Because the scope of lunch menu is inside of these curly braces. It's very minute, okay? It's the innermost set of curly braces. And as soon as the program leaves these curly braces, it gets rid of the lunch menu variable so as to free up memory so we don't melt our computer down. Okay?
Okay, you can download them over there.
There you go. There you go. So I'm moving my variable declaration up here. And if it's Monday, we're going to eat spaghetti. Okay, let's write an else if now. Someone help me do this. Else if curly brackets. There's one thing we need before curly brackets. Open close parenthesis, good. Okay, what should the condition look like here if I want to check to see if it's Tuesday? Very good. Okay, and then of course the lunch menu on Tuesday, as you all know, is pizza. Okay, so that you can have more time to practice, I'm not going to go through all the days of the week right now, but just know that I could do this for each day of the week. Okay, an if, else statement allows me to have any number of conditions to check, grouping them together. If Monday is true, we'll skip the rest of these else ifs, but if it's false, we'll go to the next else if. If this is false, we'll go to the next else if, and finally, we would go down to the final else or the final else if, okay? Any questions about any of that?
What if we didn't type a capital on Monday? Would it still?
It'd be a problem, yeah, like we learned last time, this, when we're comparing strings, is case sensitive, so we would skip that condition. And even though they typed lowercase m Monday, we wouldn't tell them that it's spaghetti, and we'd eventually be like, no lunch for you, right? Because we would trickle down to the else because lowercase m Monday is not equal to uppercase M Monday.
Why do we not have to put a semicolon after the else ifs or the ifs? Or we do everything else?
Sure, so the question is, why do we not have to put a semicolon after the if statements? And the answer is you can, but it will cause problems, right? The semicolon is the statement terminator. So it says, this is the end of the statement. When really, with an if statement, we're saying this statement is on line 14, 15, 16, and 17, right? And curly braces tell the compiler that this is a multi-line statement. Don't look for a semicolon. It's going to span several lines. Yep. When we get to loops next week, it will be the same thing, right? Repeat these statements while a condition is true. The statements grouper is curly braces.
Is there a way to have the program automatically allow for a lowercase Monday?
Absolutely.
Or include just an M for Monday, and like
Yes.
TH for Thursday?
So it's an advanced topic, but since the question was asked, I will say C# has a way to do comparisons. It's with the dot equals method. There are options that you can insert there, but it's also, because we're using Visual Studio Code and not the entire .NET framework is installed, we would have to go install that piece of the .NET framework, which I would need to research how to do. But just know that it would look something like this, equals Monday, and then parentheses, it would be, yeah, comparison, it'd be string comparison options dot ignore lowercase or ordinal ignore case or something like that. Yeah, just so that you know that I'm not a liar. Let's go out here to the end. Nope. We need time for the code along. I'll talk to you about this afterwards. Yeah. Okay, your coding assignments for the next 14 minutes, and we have the buffer today. Is that right? Did you book that? Okay, no buffer today.
Thursday is when we have the buffer.
Okay, Thursday we have a buffer. So here are your coding assignments. The first one, I want you to write a program that asks the user for a number between 1 and 100. If the number is between 1 and 100, I want you to tell them, great job. If the number is less than 1, I want you to tell them, too low, Joe. And if the number is greater than 100, I want you to tell them, too high, Sky. All right? So
Do we have to actually write those?
yes, the program will be incorrect if you don't use my cutesy language. Next question. No, you don't have to write those. You can, I mean, the whole point is a message, a distinct message if it's in between the range that we want. If it's lower, a different message. If it's higher, yet another message. Okay? It's important to do that because on the next one, we're going to write a number guessing game. All right? We're going to ask the user, first off, we're going to declare a variable with a number that we choose. And then the user has to guess it, okay? They get 3 guesses. So we're actually going to be copying and pasting some code here. You'll learn how to avoid copying and pasting that code next week. But yeah, you're going to let them ask 3 times, or you're going to ask the user up to 3 times what the number is, and then you'll give them feedback. The number was too high, the number was too low, or the number was right, right? And then if they ever guess it correctly on the first or second try, I don't want you to keep asking them. So as a hint, you either need to put if statements inside of other if statements, which you totally can do, or you need to Google how to learn or how to use the return keyword. Okay? So that's the medium difficulty one. And then the hard difficulty one, oh, Betsy. So maybe you have read the poem If by Rudyard Kipling, but it's a poem where every line of the poem begins with if. Okay, so what I want you to do is write a program that is basically this poem. Okay, so this poem goes on and says, if you do this, and 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 if you do this, at the very end, yours is the earth and everything that's in it, and which is more, you'll be a man, my son, or woman, as appropriate. Okay, so I want you to write a program that if all of these conditions are true, it will set 2 variables. The earth is yours is equal to true, and you to man equals true, if all of these conditions are true. Okay, and a thing to watch out for, if I were to do a Control F on this page, and if I were to look for all the ifs, boy, there are so many. So you know for at least every if, you're going to need an if statement, and for every and, you're probably going to need to use the and operator, and for every or, you're probably going to need to use the or operator, and this is just going to be a monstrous thing. By the time you're done, you're going to be like, throw it away. All right, I don't know if there's any knots. Oh, look at that. Okay, good luck. Best of luck to you. Okay, so that's the hard level coding challenge. I want you to take that poem, interpret it into C# code, and if all of the conditions are true, you should be setting a variable at the very end. Yours is the earth, and you to man. Okay? And we'll go ahead and end the recording, and we'll spend the last few minutes working on these and troubleshooting. So thank you.